and this is BSc Electrical and Electronics Engineering. Like I said, some of you were not here when I first introduced myself. My name is Dr. Ben Asante. All right. Um, so I'm going to be taking you through this course, and tomorrow morning, I think, yeah, I have to check the schedule again. Tomorrow morning, we have general chemistry um, for the time that is scheduled for you. So this is environmental studies for BSc Electrical and Electronics Engineering. All right. Um, I believe you guys are in level 100. And then, matter of fact, you are not on campus, you are outside. So, in case you happen to come to the campus, my office location is on the course outline, which is hostel block C. And I'm in room 56. So, when you come to the campus and want to locate me, you can go through this, go to this place and then locate me. Also, my mobile numbers are active. The 0200773728. That's my mobile number. And then also 0277383722. These are my mobile number. They are all on a WhatsApp. So anyone, if you want to reach me, you can reach me on that one. I just also had an NTN number. I just bought it today. So I don't really have, I don't have it off head. But then that one too, I'll make it available to you guys in case you want to contact me on it. Down here is my email addresses. But you can contact me on that one too. But then our WhatsApp line is always closer to us more than our email addresses. So if you have an emergency need and you want to contact me, I'll prefer you contacting me on my WhatsApp. Well, when I'm sleeping, my phone is closer to me, and my WhatsApp line is always closer to me. You understand? But if you send me an email, then I'll check my email though. But it's not like as frequent as I check my WhatsApp lines. All right. Um, any question here before we proceed? Any question? All right, no question. Okay, let's move on. You are not on campus, so this is a course description. This course is designed primarily for non-environmental engineering students. You guys are electrical electronics engineering students. So it's this course is designed for you. So because of that, we are using essential topics that relates to your field. It's why we have chosen to give it to you, right? And the aim of this course is to assist you to acquire theoretical and practical knowledge about environmental science, all right, environmental studies. So we'll talk about essential things about this course like human and nature, ecology, ozone, global warming, and stuff like that. All right. We'll talk about also population. We'll talk about environmental pollution, environmental degradation, right? Engineering projects on the environmental and control measures, right? So these are the things that we'll talk about. We'll talk also about some laws that relates to environment. Those pollution that relates to environment in Ghana. You understand? In Ghana, all right. And the main objective of this course is to introduce to you, the students, the basic concepts of environmental studies, right? We have a problem in the environment. Ghana, especially specifically in Ghana, we have a whole lot of problems. Water pollution, air pollution, which most cases we don't even care. You understand? So we'll talk about all those things, and then the way that you, the upcoming engineers, you, our future leaders, can also help to curb those environmental problems for us, for our society. All right. Um, my teaching mostly, as mandated by this course, and because you are, distant learning student, to mostly online. But there's some point in time where you will have to come to the campus for us to meet face to face, and then study. All right. But like I said, mostly it's online, and you're going to be having project work to do, and then you are going to have also mid-semester, exams. You're going to do exams, and then you are going to do the end of semester. I'll show you, the breakdown of the marks that you accumulate when you do all those things, right? So these are the books that you can really, acquire them to read when we come to the lectures. Meanwhile, you have the modules book that you have. I prepare them. All right. So you can go through them. It has homework on it. So you do the homework on it, and then you submit the homework, and that also attracts grades. You understand? So besides this semester, I'll show you this. Besides the next semester, and then the end of the semester exams, the homework also attracts grade, and also attendance also attracts grade. So these are some of the books that is recommended that you can get them to read them. All right. Besides the module book that you have. All right. So this is the breakdown of the assessment. All right. The grading criteria. Mid semester will attract 30%. The class assignment attendance will attract 10%, and the end of semester exams will attract 60%. All right. So from week by week, I've laid down what you are going to study. All right. So this is the course outline week by week, keep on going on and on and on until we finish the semester. So relax. Saying you are going to enjoy this course. But what I don't like is lateness. You understand? I hate lateness. Like, I know you are distance students. So when we start to log on, today being our first day, that's why I started, 10 minutes after. But the normal circumstances, all other things being equal, we start at, 6 p.m. p.m. straight, on the dot. But then after 10 minutes, when you come in, I won't allow you in because you see, it will disrupt the class. That's one thing with me. And we, the Africans, our time is very, we don't care about our time. I don't know the reason why. A Ghanaian will go outside, you go to US or UK or maybe Australia or any other country, the white man's country, and then he will abide by the time, and the rules there. But when we come to our country in Ghana, we don't really respect time. But for me, I respect time. My students, who are on campus, they'll tell you 10 minutes after the commencement of my class, when you come in, I'll sack you. I'll lock my door. The class will lock the door. Let's, embrace this, and it will help us a lot. You understand? Because it tells you how serious you are. You understand? It tells you how serious you are. So please, let's adhere to the time. In case it's a really extreme emergency, that one is different thing. But don't let's adopt that concept of or the Ghanaian habit of being late coming to classes and being late going to functions and being late going to this. So we'll finish it and then go and have our rest for the evening. Tomorrow morning, God willing, we'll start. We'll also learn. I have to really check the time well so that we'll meet tomorrow morning. I believe it's chemistry since I'm taking you guys for two courses, environmental studies and then general chemistry. All right. So without much ado, let's go straight ahead, and I'm going to turn off this course outline, and then I'll share another screen for you. All right. So let's see. Let me get rid of this. Let me stop sharing. Did you guys have any question on what I was saying? Any question? Any question? If you don't have any question, you can say no, so that I will know that you are there listening to me. Do you have any question?
No, sir.
No, sir.
Exactly. Very good. You see, we are online. And when I ask something, if you say yes, say yes. If no, you say no. All right. So that I can know you are hearing me. Maybe my network has gone off and I keep talking, blah, blah, blah. And then you don't hear me. And I keep talking, you understand? So when I say, can you hear me? And you say, oh, yes, we can hear you. Or any question, you say no. That means I know, you can hear me. All right, students, do you get me?
Yes, sir.
Yes, sir.
Very good. Excellent. All right. Excellent. So today we are going to talk about the foundation of life. All right. The life God has given to us. We are going to talk about it. Yeah. Foundation of life. All right. Life as we see, right, around us, talking about life, is made up of matter. Matter. And from high school, we've been defining matter, almost all the time. Yeah, we say matter is any substance that has mass and occupies space. All right. Matter is anything that has mass and occupies space. And then we also talk about elements, right? Elements are unique forms of matter with specific chemical and physical properties that cannot be broken down into smaller substances by ordinary chemical reaction, right? We can break them down, in the nuclear reaction. But in this case, well, we'll talk about more about the elements and matter and stuff like that tomorrow. You understand? Elements. All right, we'll talk about them. There are a whole lot of elements, like 118 elements, but only 92 of them, right, occur naturally. Naturally, some of them are synthesized in the laboratories. You understand? But then 92 of them occur naturally. And then, like I said, the remaining elements are synthesized in the labs, and they are unstable, right? We have 5 elements common to all living organisms, right? All living organisms, we have 5 essential elements, which are oxygen, carbon, hydrogen, nitrogen, and phosphorus. All right, these 5 of them, they are common to all the living organisms. All right. Remember that life, we have living world and non-living world. Yeah, we have living world, for us, we human beings like that, we are living beings. We grow, we have some essential, things that tell us that, oh, this thing, this organism is a living organism. Then also we have non-living organisms, living world. In the non-living world, elements are found in different proportions, right? And some elements common to living organisms are relatively rare on the earth as a whole. Some of them are relatively rare. You go to some place, you find this more of these elements. You go to other place, you find more of this element, and then the other place too, you find less of that element. But then when you go to the other place, you will find more of those elements. All right. For example, the atmosphere is rich in nitrogen and oxygen, but contains a lot of carbon and hydrogen. So when you go to the atmosphere, right, nitrogen and then oxygen, a whole lot of them, but then you have a little of carbon and hydrogen. And when you go to the earth crust, the earth, it contains more oxygen and small amount of hydrogen, but has a lot of nitrogen and carbon, right? But all elements and the chemical reaction between them obey the same chemical and physical laws, regardless of whether they are part of the living or non-living world. Let's see. Fine. Look, the biosphere, the atmosphere, the lithosphere, all right? See, oxygen. When you go to the biosphere, right, the biosphere, where we have the living part, all right, it has 60%, 65% of oxygen. Then atmosphere, right, the air surrounding us, all right, we have 21%. The lithosphere, and on the ground, we have just 46%. Much the same with carbon, right? When you go to biosphere, it's 80%. Then it's a trace element. We have a trace of it, carbon in the atmosphere. Then we go to the, also the lithosphere, we have trace of it. Hydrogen, when you go to biosphere, 10%. Atmosphere, you have the trace, and then when you go to the lithosphere, you have a trace of it. Nitrogen, 3%. When you go to biosphere, atmosphere gets 78%. All right. And then lithosphere is have a trace, and phosphorus trace, and atmosphere trace, and lithosphere. We have way less than less than 30. I mean, it's greater than 30%. All right. So air, let me ask you this question. What does air contain? What are the elements that is constitute air? Can you give me an example of them? Some of the elements that air contains. A question. If you know it, you can just raise up your hand and say it. Go ahead. Kingsley, class rep.
Sir. I'm not 25 to the phone. 25.
Kingsley, what does air contain? Yeah, Raphael. Dakun.
Yeah, so please, air contains oxygen.
Very good. Somebody is talking. Mute yourself if you are not talking. If you haven't raised up your hand and you are talking, I mean, you haven't raised up your hand, I've called you. It seems like you are talking in the background. Mute yourself. When you want to talk, you raise up your hand, then you unmute yourself, okay? That's what we do. All right, so Dakun is saying that air contains oxygen. What other elements that air contains? Kingsley.
Sir.
Kingsley again. Kingsley, what other element does air contain?
Sir, oxygen and carbon dioxide.
Oxygen and carbon dioxide. Okay. All right. So then, let me ask you, how much of oxygen, the approximate, all right, that's air contained in oxygen is inside the air. Who can tell us? Okay, Ernest.
21%.
21%. Good.
Yes, please.
This is approximate amount, though. 21% is approximate. And then Kingsley, your hand is up.
But it's 21%, I wanted to say.
21%, okay. But there's one also element that is constitute the air. Is plenty of them, in the air. Who can tell us that one? Plenty of them is in the air. Matter of fact, that's the one that constitutes the most of air. What is that one? Okay, let me see. Who am I calling? Okay, Nana. Kingsley, are you telling us the answer?
So please go and count.
Okay, Raphael. No, you should.
LSA.
Which one?
I'm thinking it's nitrogen.
Yeah, you're right. It's not you are thinking. You are right, Raphael. See, we are learning. Here is a learning atmosphere. So when you say it, I haven't seen your face before. I see your picture there. I haven't seen you before. So when you say that even you are wrong, Prana, you are just learning. You understand? So you are contributing. It's a contributing factor. So you just say what your mind, whatever you think is right. Like how, Raphael said he thinks, she's right. It's nitrogen. It constitutes about approximately, if you say oxygen as about 21%, then nitrogen we can say also about, it's even right here on the screen, it's about 79%, right? So most of the time we cut the stuff off. Now when we are doing reactions, chemical reactions like that, or the small ones, the trace ones, we don't talk about them. We just leave them behind and say, oh, air contains 21% of oxygen and then 79% of nitrogen, all right? So let's move on. Now we are going to talk about atom, right? Atom. Atom is defined as the smallest unit of matter that retains all of the chemical properties of an element. Right? When you take an element, for example, you take gold, or you take diamond, you take bauxite, manganese, all those elements. That's the smallest part. You go all the way down to the smallest part of it, smallest part of it. That's why we say it's an atom. right? So atom is the smallest unit of matter that retains all of the chemical properties of that element. For example, one gold atom has all the properties of gold in that it's a solid metal at room temperature, right? So if you take a gold coin, for example, it's simply the very large number of gold atoms molded together to the shape of a coin and contains small amounts of other elements known as impurities. All right, so you take a gold and then you say, okay, let me see. Okay, atoms. And atoms are the smallest part of the of the gold, and you put them all together, then you get a gold coin. Take silver, cut them to pieces, go all the way down to the smallest part. And when you go down to the smallest part, put them all together, then you get a silver chain, silver, jewel that we put on our neck, and then some of them on our wrist, and then whatever. You understand? So that's how it is, right? And gold atom, for example, cannot be broken down into any smaller while still retaining the properties of gold. All right. And this is the structure of atom. All right. This is the structure of atom. You see what it is there. You see inside here, we'll talk also about it. This atom and atomic structure and whatever we are talking about it tonight, we'll talk about them in course of time. Because this is life, that's how life goes. All right. So this is you see the middle here. We have the neutrons, and then the protons. We call that place the nucleus of the atom. Of the atom, right? So we have the nucleus of the atom, and inside the nucleus, we have the protons and the neutrons. And we have the electrons on the outside. All right, you see this place, this is electron, this is electron. This is just a structure of an atom. All right. Any question here about the atom before we proceed? Okay, let's go. Let's go. Sometimes if you don't ask me question, I'll give you questions. If you don't ask me question, now all your names are here. So I'll call you randomly. All right. And it doesn't matter whether you get it right or you don't get it right. We are learning. Nobody is perfect here. Do you get what I'm saying? So when I ask a question and then you think you can share your ideas, share your ideas. Okay. So this is the structure of atom. We have the nucleus, we have which contains the neutrons and the protons, and we have the electrons, and also around the nucleus, right? So like I said, atoms contain protons, electrons, and neutrons, among other subatomic particles. The only exception is hydrogen, which is made up of one proton and one electron with no neutrons, all right? Protons and neutrons have approximately the same mass. Protons and neutrons have approximately almost the same mass, which is 1.67 times 10 to the power minus 24 grams. All right. So this is a physical constant. When I say it's a physical constant, when you are looking for the mass of a proton or the mass of a neutron, all I need to do is just look for a book or go to the internet and they say, okay, Google, what is the mass of a proton and neutron? It just pop up. This is not something you are going to calculate it. You understand? It is there. But unless maybe you are giving some question, that you have to, but it's there. You understand? Go to the net or go look at a book, maybe a physics book, environmental stuff. Some of the books are there, looking through it. And then it will just give it to you, like a mass of those, the charges. They are all there, right? This is defined as one atomic mass unit. So this 1.67 times 10 to the power minus 24 is defined as mass of atomic mass unit. And then these particles that I'm talking about, that is made up of that they are in the atom, right? They have charges, right? Proton has its charge, neutron has its charge, electron has its charge. And here, proton is positively charged, positive, right? Positive charge. Neutron, no charge, right? Neutron, no charge. right? The number of neutrons in an atom contributes significantly, right, to its mass, but no charge. That because it's neutral, it doesn't have a charge, right? Proton has a charge, and neutron does not have a charge. So here, look at it. So the charges are the charges of the particles in the atom, right? You see that proton has a positive charge, neutron zero, no charge, electron negative charge. All right. The mass unit, this is one. This is one. I'm talking about the proton is one, the neutron is one, and then electron zero. You see zero mass, atomic mass, because if you compare the mass of electron with the mass of neutron and proton, you see electron is very, very, very small. It has a mass though. If it does not has a mass, then it will not be a mass because it has a mass, but very, very small. So we ignore it. We say it's essentially zero, right? We say it's essentially zero, all right? And where are they? Their location in the atom, right? The nucleus is in the proton is in the nucleus, the neutrons is in the nucleus, and the electron is around the orbital. We call orbital means where the electrons are located around the nucleus is where we say is the orbital, or where this thing is hiding, the electron is hiding. All right, we say they are in their orbitals. All right. So electrons, like I said, electrons are much smaller in mass than proton, weighing only 9.11 times 10 to the power minus 28 grams, or about 1 over 1,800 of an atomic mass unit. So we ignore it. It's very, very small. All right. So it's like somebody gives you, one person right now. Compare with that your money, even if you have 10,000 or 1,000 Ghana in the bank, and somebody you see, even if you see one person on the ground, you won't pick it. I know you will not pick it. You understand? Because it's very, very insignificant. So you need the money. So same with the electron. It's not like they don't have a mass. It's not like they don't have mass. They have mass, of course, but then it's very, very small. So become insignificant when we are talking about the mass of the atom. All right. But the electrons contribute greatly to the atom's charge. All right. It contributes greatly to the atom's charge. As each electron has a negative charge equal to the positive charge of a proton. So if you have one proton and we have one electron, their charges will cancel off, right? Even though this one is positive and this one is negative, they will cancel off. The charges, electron is very powerful, in the negative charge, all right? Very powerful in the negative charging. So if you have one electron, one proton, the charge will cancel off, give you zero, all right? In an uncharged neutral atoms, the number of electrons orbiting the nucleus is equal to the number of protons inside the nucleus, all right? So if you have a neutral atom, all right, or uncharged neutral atom, all right, that means the number of protons are equal to the number of electrons because they have the same amount of charges. So they've canceled off that. It tells you that you have, the same amount of neutrons, the same amount of electrons. So in these atoms, the positive and negative charges cancel each other, leading to atom with no net charge. Right? Accounting for the sizes of protons, neutrons, and electrons, most of the volume of an atom, greater than 99%, is in fact empty space. Right? So most of the part of the atom is an empty space. So you can say, oh, okay, without the empty space, with all this space, empty space, why is it that the electrons don't really go through it? The reason why they do not go through is that the electrons that surround all atoms are negative charged, and the negative charges repel each other. Like charges repel each other, negative charges repel each other, so they will not go through it. Right? When an atom gains or loses an electron, it becomes an ion. Right? So we're talking about ion that we're hearing all the time. It's either the atom has gained electron or the atom has lost an electron. When the atom gains an electron, right, becomes what? It becomes negatively charged. When the atom loses an electron, it becomes positively charged. Why is this so? Somebody should tell me the reason why when atom gains electron, it's a negative charge, and when it loses an electron, it becomes positive charge. Am I running too fast? Can you hear me? Can you hear me? Kingsley, can you hear me?
Yes, sir.
Good. I'm asking a question. All right. It's sharing ideas. Somebody should share his idea with me. The reason why, we have positive charge ion and then negative charge ion. Why is it so? Let me see the names that I can see. I've been calling Kingsley. Let me see the rest. Bernard, Samson too is there. Elvis is there. All right. Yeah, Bernard, you contribute something. Why is it that, Bernard, why is it that an atom becomes an ion? What happens?
I think because of they are in the same inside the orbit. That's why
they become negatively charged?
Yes.
Okay. Bernard has said something. Anyone who can also help? Any contributor? Kwame Kuma, you are there. Don't hide yourself.
Okay, sir.
Kwame,
Yes,
say
sir.
something. Yeah, go ahead. Why is it that an atom becomes ion? When atom becomes an ion, okay, let me put it this way. Your question is this: why is it that when?
Okay, sir.
Go ahead.
Sir, I think some
Kwame,
of
go
these
ahead.
materials. It's Philip speaking.
Philip. All right, Philip, go ahead.
Yes, sir. So, sir, some of these atoms, because the electrons at the outermost shell uh, on the outermost shell are not stable. Sometimes they give away so that they will be stable. So, because of that, when they donate or they give away, then they become stable and become positively charged for them to conduct.
Very good. Now, you have said this, you have contributed nicely. I want somebody to tell the reason why it becomes, when it gives away, an electron, it becomes positively charged. Why? Why is it so? Why is it so?
Okay, sir. So on the non-conductive materials, on the outermost shell, the electrons are closely packed, so the electrons cannot move. The electrons cannot move. So on the conductive materials, they have only like one or two electrons and which orbit. So they I'm lost.
Don't worry. Don't worry. No, listen. Don't worry. You've done your best.
I'm trying to remember. I'm trying to remember.
You've done your best. You've done your best. Don't worry. You've done your best. You see, it's better you say it than somebody who is sitting down there. Let me go through the list. Okay, Elvis, I see Elvis there. Elvis, also say something. Elvis, say something for us. Why is it so? Why is it that when an atom loses an electron, it becomes positively charged, and when it gains an electron, it becomes negatively charged? Elvis, help us. Say something. Elvis, on country. All right, no problem. Okay, let me come in here, all right, so that we can move on. You see, like I told you before, a neutral atom, right? When you have an atom that has no charge, now that means the number of positive, the electrons, right, and the number of protons are the same. right? Because protons contains positive charge, and then electrons contains negative charge. So when they are the same, they cancel off. For example, I have 5 protons that has positive charge. I have 5 electrons that have negative charge. So positive 5 plus negative 5, when I combine them, I get 0, right? So when an atom gains 1 more electron, and now the atom has gotten 6 negative charges, right? And then the protons are still 5. So now it has, when you combine them together, then you see that you have -1. So then the atom will be negative charge. In much the same way, if you have 5, 5, and then the electrons are 5, the protons are 5, and then the atom has donated, move away 1 electron. Now you see that it's, because it was 5, and then it has given away 1 electron, it becomes 4 electrons. You understand? And now the protons remain the same. The protons, the atom, they don't give away protons. The protons are always the same. It's the electron that are moving away. Why? Because they are outside. So when the electron move away, 1 electron, right? The atom move away 1 electron. Now electron has become, 4. And the protons are now 5. It's still 5. So now the charges, which is positive, will dominate the electron, which is negative, by 1, positive 1. So now the atom become positive charge. That's why we have the positive ions and negative ions. Is it clear? Is it clear?
Yes, sir.
Very good. Someone for
No, sir.
Say again.
Sir, please, not clear.
Okay, let me go over it again. All right. If you have a pen and paper, write this down. Write +5 and -5. Write them down. Everybody do the same thing that someone is also doing. +5 and -5. All right. -5 or +5.
Oh.
When you combine -5 and +5, all right, it's 0. It's like 5 plus -5. Won't you get 0? Is everybody get 0?
We'll get 0.
0.
Very
Yes, sir,
good.
it goes 0.
0 is on.
Very good. So now, on your right side, on your left side is positive charge, and on your positive protons. Let's say protons, and then on your right side is the electrons, right? So now add 1 electron to the 5 electrons. Add 1 to it. How many electrons do you have now?
6.
How many?
You are adding, so 4.
No, you are adding 1 electron to the 5 electrons. How many electrons do you have now? You started with 5 electrons. You have added 1 electron to the 5 electrons. How many electrons do you have now?
That's 6 electrons.
6 electrons, right? Because you started 5, 5. 5 protons, 5 electrons. You have added 1 electrons to the 5 electrons. Now you have 6, isn't it? But then the number of protons remain the same. So now when you combine +5 -6, what will be the answer? +5 and -6. What will be the answer?
-1.
-1, NS. NS is -1, right? Everybody is -1. +5 -6. When you combine them, you get -1 because the minus is more than the plus, isn't it?
Yeah.
So if you have +5 and you have -6, -6, and you combine them, for example, let me give you for example. You have 5 cedis in the bank, right, which is plus, and you go to the bank, and you are permitted to withdraw more than you have, right? But then if you withdraw more, you get lost, right? And you go and withdraw 6 cedis. You have to pay the bank 1 more cedi, which is negative. That's why it goes. So +5 -6 will give you -1. Because you didn't have it. So you have 5 protons and then 6 electrons, which is negative and positive. So you have -1. That's why when the atom, it gains 1 more electron, becomes negative. If it's a neutral atom, which is in the beginning, they are all protons and then electrons are the same. So if it gains 1 more electron, then it becomes negative charge. Why? because it has gained a negative, electron together with it. It much the same way. You started 5 protons, 5 electrons. Now the atom has given away. It has given away, donated 1 electron. So how many electrons do you have now? I'm asking you. If you know, just say it.
4.
4. Very good. And how many protons do you have?
5.
Raphael, say it louder. Yeah, right. Say it.
5.
5. Good. Now you have 5 protons, 4 electrons. And then protons contain positive charge. Electrons contain negative charge. So your atom, which charge will it be? Dominate.
Positive 1.
Exactly. So now you have positive ion. So when an atom donates electron, it becomes positive charge. And when it gains electron, it becomes negative charge. Is it clear now?
It's clear, sir.
Yes,
Very
sir.
good. Very good.
Yes, sir.
Very good. Let's move on. All right. A positive charge ion such as sodium has lost 1 more electron, right? That's why we get positive. This is an example, but then we have really understood it. The concept of positive charge and negative charge. So let's move on. Now let's talk about molecules. All right. Let's talk about molecules. Molecules are formed when 2 or more atoms join together through chemical bonds to form a unit of matter. But when we do chemistry tomorrow, you will see that some of the elements exist as molecules naturally. Like how naturally, maybe you are fair, naturally you are dark skin. If you are dark skin and you go and bleach yourself, that one is not natural. Natural. You understand? We're talking about your natural color. If you are tall or you are short, you are fat, or some people now they are fat, they can go on a diet though. But we're talking about your natural, predisposition, how God created you. There are some of them, the elements. Right? Some of them are naturally, molecules. Right? So we'll talk about them. God willing, we'll do chemistry. This is environmental studies. Because we're talking about the foundation of life, so we have to, see things that are around us. The chemicals. The things that are really going around us, right? Molecules are formed when 2 or more atoms join together through chemical bond to form a unit of matter. Example of molecules: carbon dioxide, the carbon dioxide gas. This chemical formula is CO2. All right, CO2. This indicates that the molecule is made up of 1 carbon and carbon atom and 2 oxygen atoms. Some molecules are charged. Now you understand the charges, right? And the concept that I showed. Some molecules are charged due to the ions they contain. All right. This is the case for the nitrate. It's 1 atom of nitrogen and 3 atoms of oxygen. So this is a common source of nitrogen to plants. It contains 1 nitrogen atom and 3 oxygen atoms. And it has an overall charge of -1. You see under the superscript here, up there, it's -1. All right. Up there, it's -1. All right. Now we're talking about isotopes. Who has heard about isotopes before? Who has heard about isotopes before? Who can tell me? All right. What is an isotope? What is an isotope? All right, isotope. All right, let me come in here. So if somebody want to talk, if you want to talk, you can unmute yourself and talk. That's an isotope. Okay. Some isotopes may emit neutrons, protons, and electrons, right? And attain a more stable atomic configuration. lower levels of potential energy. So the isotopes, right? For these isotopes, right, those that emit either proton and electrons and the neutrons, right? We call them radioisotopes, right? We call them radioisotopes or radioactive isotopes, right? The isotopes, they contains, remember when we have a neutral atom, right? Neutral atom, the number of protons are equal to the number of what? Electrons. And we know now, we say that the electrons are those particles that are going around the nucleus, all right? And then the protons are the one that is inside the nucleus, and then it's also there with the neutrons. But then there are some elements, for example, carbon like this, inside the nucleus, inside the middle of the atom, inside the nucleus, the neutrons are different when you have different isotope, right? Different isotope. For example, carbon 14 like this have different amount of, neutrons, and then carbon 12 has different amount of neutrons, right? So that's why we say this is carbon 12, okay, this is carbon 14, all because the number of neutrons in carbon 14 is more than the number of neutrons in carbon 12. In carbon 14, the neutrons are 8. 1, 2, 3, 4, 5, 6, 7, 8. But when you come to carbon 12, the neutrons are only 6. 1, 2, 3, 4, 5, 6. So the same element carbon, so that's why we say carbon isotope, because the number of neutrons, when you take some of the carbon, take this carbon contains, 8 neutrons. Take the same carbon from, maybe some other source, you don't even know where you take it from. It contains 6 neutrons. So we say carbon isotope. Right? It's an isotope. So the same element, but then it contains different amount of neutrons or atomic mass. Because remember, let me show you this, because I keep going back and forth telling you that we study in chemistry. This is, we study in chemistry. So when we reach chemistry and are going, and when we reach there, become a revision for you, then you know that, oh, Dr. Ben Asante taught us just because I'm going to meet you the same people in the chemistry. Then I don't have to talk too much when I'm talking about the isotope chemistry. You get it? So that's why I take my time over here and going over there with you. You understand? So this is the thing. It's it's an element that contains different amount of carbon. Mass, because the mass is constitute the protons and the neutrons. The protons and the neutrons. Remember, we said earlier on that we ignore the mass of the electron because it's very, very minute, relative to how much the mass of the neutrons and protons. So when I'm talking the mass of an atom is the mass of the protons and the mass of the neutrons put together. Then you get the mass of the atom. So in this case, isotopes are the element that contains different amount of mass. Because, for example, carbon 12, its mass is 12 grams per mole, and the carbon 12 is 12 grams per mole, and carbon 14 is 14 grams per mole. Understand? So that's how it goes. All right. Now, carbon that we are talking about, carbon. Right? I know everybody has heard carbon. Who has not heard carbon before? Raise up your hand. Or tell me, have you heard about carbon before? Who has? Okay, let me put it this way. Who has heard about carbon before? Who has heard about carbon before? Nobody is answering me. Hello. Kwame.
So we are showing by hands.
You are showing by hand. Oh, okay. Now, have you heard about carbon before? Just omit yourself and say it.
Yeah.
Okay. Samuel, Afari, have you heard about carbon before? Samuel, Afari, Ajay.
Hello, sir.
Ajay, have you heard
Hello,
about
sir.
carbon before?
Yes, please. I've heard about it before.
Oh, okay, that is good. That is good. What about Kuma? Dozie. Dozie. Kwame Dozie. Kwame Dozie. Kwame. Kuma. Kwame, don't log on and then go and put your phone somewhere and as if you are there and then you are doing something else. That's why I call your name to make sure you are there. Some students, what they do is this: they will log on and then they'll put their their phone. You see them there online. That's why I be calling. I'm warning you because some people will just log on and then they'll put their phone somewhere and they'll be doing something else. Oh, after all, I was there, but you were not there. So I'll be calling your names. Yes, I'll be calling you to make sure you are there. So if you are there, then you respond. Because I'll mark attendance. This one shows attendance. Attendance is also part of the. Because if I be calling your name and you don't respond, that means you are not there. Sometimes I'll even call your name and then I will, you just tell me that I'm there. Say, then I'll know you are there. Bernard. Ben.
Yes, sir. I'm here.
Good. Bernard, you are there. Bernard, have you heard about carbon before?
Yes, sir.
Good. Well done. Well done. All right. So the basic functional unit of life is a cell, right? The basic functional unit of life is a cell. And all organisms are made up of one or more cells, right? One or more cells. Right? Cells are made up of many complex molecules called macromolecules. Cells are made up of many complex molecules called macromolecules, such as proteins, nucleic acid, which is RNA and DNA, carbohydrates, and lipids. All right. So what is RNA and DNA? What is RNA? What is RNA?
Ribonucleic acid and deribonucleic acid.
Well done. Who said it?
Alexander.
Alexander, well done. Ribonucleic acid and deoxyribonucleic acid. Right? The macromolecules are a subset of organic molecules that are especially important for life. Now, these organic molecules, they are very important for life. All right. The functional component for all these macromolecules is carbon. That's why we're talking about carbon. Very, very important. You understand? It's a fundamental component of all these macromolecules. Right? The carbon atom has a unique properties that allow it to form covalent bonds. We'll talk about covalent bonds, right? And then we'll talk about ionic bonds. We'll talk about coordinate covalent bonds, right? It forms four different, it can bond with four different atoms, making a versatile element ideal to serve as the basic structural component or backbone of the macro molecules, all right? Then we talk about the hydrocarbon, right? Hydrocarbon. They are organic molecules consisting entirely of carbon and hydrogen. That's why hydrocarbon, hydrogen and carbon, hydrocarbons, right? Something like, methane, CH4, they are hydrocarbon, right? Some of the hydrocarbons is what we use in our house, the one we use to cook, like the LPG and, other stuff, gasoline that you put in your vehicle, all right? Those ones that you put in your cars, those are the hydrocarbons. The many covalent bonds between the atoms in the hydrocarbons store a great amount of energy, which is released when these molecules are burned. When they are oxidized, right? When you burn them, they release energy, all right? So they are very, very important, the hydrocarbons in life. And they are very, very important in life. Hydrocarbons are the backbone of the large molecules of living things. Hydrocarbons may exist as linear, carbon chains, carbon rings, or combination of both. The three-dimensional shape or conformation, the three-dimensional shape or the conformation of the large molecules of life is critical to how they function. All right. So the way that the shape is also commensurate with how they function. Like, the methane that we saw, CH4 methane that we saw before, is the simplest hydrocarbon molecule with a central carbon atom bonded to 4 hydrogen atoms. All right, this is how it is. We have the central atom, which is a carbon, and then it's bonded with 4 hydrogen atoms. This is hydrogen, 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 hydrogen. And then the angle between them, one hydrogen and another hydrogen and another hydrogen, there is 109.5 degrees. All right. 109.5 degrees. All right. So that's how it is. If you hear, this is a structural diagram, and this one is like, when you want to put some kind of, dot to represent the methane, you see the carbon in the middle, and then the hydrogens are bonded to. So the angle between them is 109.5. All right. Any questions so far? All right. If there's no any question, all right, just a second. Any question? No question. All right. So let me make it smaller a bit.
Sir, please, some hands are up.
Yeah, go ahead. Go ahead. Ask your question. Just unmute yourself and ask your question. Unmute yourself. You can unmute yourself. The mute, when I say unmute yourself, that means you can just there's some portion that you can tap to
Let me come in. Okay, go ahead.
Engineer Flipper. Engineer.
Yes, sir. Yes, sir.
Go ahead, engineer.
Sir, please, are carbons always black?
Carbon always plus.
Black in color.
Black in color. Yeah, it's a color that we represent it for carbon. Yes. Yes, it's a color that we use to represent carbon.
Okay.
Yeah. I can see you here. Okay, I see all my students. I see Alexander, Dozie, Kuma, Engineer Flipaita. Is it Aita or Aita?
Sir, it's Aita.
Aita. Okay.
Yeah.
And I see Bernard Arthur, Dozie, Kwame, Kuma, Ernest, Nana Wilson, Kingsley Avoga, and Manuel. Manuel what? When you come here, right, put your whole name there because I'll mark the this in the attendance. All right, today we are 13. All right, that means you guys are how many? 1, 2, 3, 4, 5, 6, 7. 7 of you attended today. And then we have the ICD support host, and then we have co-hosts. All right, they're helping us. They're making sure that our system is working properly. So that's great. All right. So then, next time, tomorrow, tell your friends that's Engineer Dr. Ben Asante, who's going to take you for chemistry. So I expect you to be here on time and tell them that, Dr. Ben Asante, he doesn't like, late. Doctor, he doesn't like late. So you can just log on time. All right. Because of you guys, I went to buy, this table, this thing. It cost me 1,200 Ghana cedis. All right, for MTN. Today, I bought them today. So my it's not breaking up. All right. 1,200 Ghana. I bought data 50 Ghana cedis on it, which cost me about 1,250 Ghana cedis, and everything is it hasn't broken down. Last night I tried to do online studies and then it was disaster, all because it was breaking up. So today I said, no, you know what? I'm going to buy more. This the MTN, they have this kind of new stuff. All right. So I went to buy 1,200. What's so small? I live closer to the West so small. I went in there and I got it. You see that it hasn't broken down. All right. So then tell your friends that Engineer Dr. Ben Asante, I don't like lateness. And let's log on time and then study, okay? It's for you, just it's the course is for you. All right. So let's keep on learning. All right. Let's talk about biological molecules. Life on Earth is primarily made up of 4 classes of biological molecules or biomolecules. Right? Biomolecules. I talked about it on the other side. I say carbohydrates, we have lipids, we have proteins, and we have nucleic acids. And that's how our friend told us that we have a ribonucleic acid and deoxyribonucleic acid. RNA and DNA. Right? RNA and DNA. Right? Carbohydrates. Let's start with carbohydrates. Carbohydrates are one type of macromolecule. Carbohydrates are essential part of our diet. Carbohydrates are essential part of our diet. What we, whenever we eat. And in Ghana, we eat carbohydrates. Kabobo, we eat a lot. All right, our banku, our gari, what cocoyam, yams, a whole lot of carbohydrates. An example are the grains, the fruits and vegetables, a whole lot of them. For Ghana, most of our diet is more carbohydrates. You understand? They are natural sources of these ones, grains, fruits, and vegetables. They are natural sources of carbohydrates. Carbohydrates provide energy to the body, particularly through glucose. But when you break down carbohydrates all the way down, to the latest part, the one that our body absorbs into our bloodstreams, they are glucose. Glucose is a simple sugar that is a component of starch and an ingredient in many staple foods. Staple is not carbohydrate. Somebody's eating fufu, right? Either they use plantain or they use cassava or cocoyam or whatever they make fufu. And some people say, oh, especially the airways, even accounts people are also eating fufu. And some of them say, okay, we don't like fufu. Some of them eat rice, carbohydrates. They will eat what you call it, benkun, carbohydrates. They will eat akple. The airways people eat akple, carbohydrates. Carbohydrates a lot. Gary, gobe. Gobe, they say carbohydrates is in there, Gary is in there. Right? They're all natural sources for carbohydrates. Right? They give us energy. Carbohydrates provide energy to the body, particularly through glucose. And glucose is a simple sugar that is a component of starch and an ingredient in many staple foods. Carbohydrates also have other important functions in humans, animals, and plants. All right. So you see that this is called stoichiometric formula, CH2O. And then you see that the N down there, the subscript N, right? The N there, right? N is a number. It's a number, right? So the N is the number of carbons in the molecule. N is the number of carbons in the molecule. So the carbohydrate that you see is in a ratio of 1:2:1. Right? Carbon, hydrogen, carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Carbohydrates. Right? Carbohydrate. Right? As 1:2:1. Arranged in that form. So, for example, right, C6H12O6 is a formula of glucose. So, in this case, the N here, what is the number N here? Who can tell me? If I see CH2O, and now it tends to be C6H12O6. What is the number of N here? Who can tell me? If you have raised up your hand, just unmute yourself and talk. Philip, engineer.
Sir.
Engineer, what is the number of the N here? The N here. Say it again.
Look like nitrogen.
And I'm talking about the N at the back here. Let me see at the front here. What is the N here? See where the cursor is?
Yes.
What is the number of N here? Now, you have CH2O, and I have turned to be C6H12O6. What is the N there?
Constant or?
No, sir.
Yeah, who's yeah. Who else? I saw somebody trying to say something. What is the N?
It is number of carbons in a molecule.
Okay, so the N, what number is this? Now we have C6H12O6. What is the number of carbon in there?
Sir, please 6.
How many?
Six.
Well done. I'm trying to see whether you are following whatever I'm doing or not. Yeah, it's 6. So we have the N here, which is 6 here. If you multiply 6 throughout the subscript, you have C6H12O6. All right. In humans, glucose is an important source of energy, right? So when you are sick, when we want to, for example, somebody is sick, I won't say you, because nobody want to get sick anyway, but then we do get sick sometimes. So when somebody gets sick and he goes to the hospital and say, oh, this guy cannot eat, or you lose your appetite, and they want to give you energy, they give you IV, they give you also glucose. They put it in some kind of rubber saline, and they put saline also in it. They put in a protein also in it, and then they give you IV. They put in an IV to give you energy. They give you glucose a lot, right? I remember some years ago when we were kids, I don't know whether they still do that, because now, I'm getting old, so I don't really run that much. But I used to run. I used to be a good athlete. The last time I made my competition, I ran 9 miles in 11. I mean, 2 miles in 11 minutes. I used to run a lot. You understand? And then now, because I'm getting old, so I don't run that much again. You understand? And that was when I was in America. You understand? And this is the thing. When people run and they get tired, they be like, yo, this guy's dying, man. And then they give the person, if they want to, give you energy, they give you glucose. All right? Sometimes, I don't know whether it's still the same form that they used to give to people, but then, they have some kind of whitish, glucose like that, and then they give it to somebody, and then the person will be like, and then the person will get his energy back. So glucose is an important source of energy. All right. That's why we Africans, we are strong. And yes, we are strong, because we eat a lot of carbohydrates. But you need to eat balanced diet though. Because you say glucose will give you energy, then all carbo, you need to balance your diet, right? You balance your diet. All right. During cellular respiration, energy is released from glucose. All right. That is used to help make adenosine triphosphate, ATP, right? Plants, the plants that we see around, they also synthesize glucose using carbon dioxide and water. All right. What is photosynthesis? Let me ask you guys. If somebody knows what is photosynthesis, you can just tell us, what is photosynthesis? What is photosynthesis?
The process by where plants make their own food by the help of the sunlight and
Very good. So when the human beings, me and you, right? What do we take in and what do we breathe out?
So we take in oxygen and breathe out carbon dioxide.
Very good. We take in oxygen and we breathe out our carbon dioxide. And where do we get the oxygen from?
From the trees.
Very good. See, the trees. You see, that's the reason why sometimes I don't understand as we the Africans. we Ghanaians, let me say, I won't say Africans, because when you go to some part of Africa, they are conscious of all those things. But we Ghanaians, what is wrong with us? Students, we need to plant trees. We need to plant trees. All right? Because these trees that we are planting, that is around it, they give an oxygen. And we can get this oxygenized air from these trees. You understand? And then, when we breathe in, breathe out. And when we breathe in and we breathe out, right? We breathe out carbon dioxide. We take in oxygen. These plants are giving an oxygen. And then these plants are taking out, they're taking the carbon that we are breathing out. So that these greenhouse gases, our atmosphere will not be so, warm. We'll talk about them. How the ozone layer is really depleting and how we can preserve our environment. Do you get it? So in this case, why don't you plant trees in your house? When you come to my house, I bet you, I have planted trees in my house. I have coconut trees in my house. They are because you see, I wanted to plant a tree whereby it can give me food to eat, right? So coconut gives me food to eat, and also I can also get oxygen from them. So if you want, when you come to the Western Small, you call me. The dog, I'm your student, and I'm over at Western Small. I want to come and see your place and come and see how many coconut trees I've planted in my house. I have 15 trees in my house. You understand? So that I can get oxygen. I can also get, food to eat. The coconut, I even sell it to some of my neighbors. You get what I'm saying? So me and you, we can plant trees. Plant trees that can also, give you food to eat. So why don't you like the whole nation, Ghana, the whole nation? Sometimes we just talk, we are planting trees. But our environment is very hot. You drive all over, you go a lot of places, and then, there's no tree. So these trees, they give us, oxygen. Our places are, go to places where there's, trees. The place is calm. You can breathe in nice oxygen. I understand, very nice oxygen. You go to Accra, you've cut down all our trees, right? But we need to have our trees. Even the white man country, where it's very cold, they even plant trees there. I don't know whether some of you have traveled abroad before, but you travel abroad and go and see. You plant a whole lot of trees. And you see, you have a Ghanaian who are, building places over, where we have reserve as a carbon sink in Ghana. You go to Achimota Forest and people are building houses there. In a forest whereby we have made like carbon sink. All because the carbon that is in the air or that we are breathing out and it's while around in the air, those trees are taking them. Right? They're giving us oxygen. If you go to America, you go to Central Park, go to Prospect Park, Brooklyn. My house was close to the Prospect Park. A whole lot of trees. They planted trees. A whole lot. You can go for jogging there. You can do a whole lot of things there. And we, our country, Ghanaians, Africa, where there's sunshine, a whole lot of sunshine, that can even the sun can give us melanoma, skin cancer. Instead of we planting trees, we talk about them. We talk about the rays that come from the sun, the UV rays that come from that. We talk about them. You understand? So you, the elite, you are now in the university. You are in the university. So you have put yourself in the elite group. You understand? And now you guys have to take the mantle. You're cutting tree, you plant some. You cut tree, you plant some. And you can plant where there's no trees, to plant trees there. And our environment can be so nice for me and you. Right? Plant synthesize glucose using carbon dioxide and water. Glucose is in turn used for energy requirement for the plant. And excess glucose is stored as starch, right? Stored in the plant as starch. So you go and take your cassava, you make your gari, you make your what you call it, agbalekla, you make yaka, you make fufu, you make different type of food, with those things. Those are the starch that is stored in the plant. That starch is catabolized. Catabolysis means the breaking down of large molecules by cells, by humans and other animals that feed on plants. All right. Plants are able to synthesize glucose, and the excess glucose beyond the plant's immediate energy need is stored as such in different plant parts, including roots and seeds. The starch in the seeds provides food for the embryo as it germinates, right? The starch can also act as a source of food for me and you, for we the humans and then animals, all right? Lipids include a diverse group of components such as fats. Now we are talking about lipids, fats, oils, waxes, phospholipids, and steroids that are largely nonpolar in nature. They are nonpolar, right? In nature. Non-polar molecules, we'll talk about polarity, and those who are polar, the molecules that are polar and non-polar in chemistry. Understand? Non-polar molecules are hydrophobic. When you say hydrophobic, that means they don't like water. Water fearing. They don't like water. Hydro means water and phobic means fear. Right? Hydrophobic. Water fearing. Or insoluble in water. You put oil inside water. You see that the water, they will immiscible, they will cannot mix with those oil, right? They are immiscible. Water inside, you see that the water, because of the difference of the density, you see that water will be, the lipid or the fat will be floating underneath the water. And so these lipids have important roles in energy storage, as well as in the building of cell membranes throughout the body. That's the reason why you don't take only carbohydrates, you take also fats, right? Without fats, all these carbohydrates cannot work, So you need some fat in your body, so that they can help the catabolism, Right. Then we talk about proteins, all right? Proteins are one of the most abundant organic molecules in living systems. They have the most diverse range of functions of all macromolecules. They may be structural, regulatory, contractile, or protective. So these are the functions of the proteins, right? They may serve in transport, storage of or membranes. They may exist as toxins or enzymes, right? They may exist as toxins or enzymes. Each cell in a living system may contain thousands of proteins, each with a unique function, all right? So we have, the cell contains a whole lot of proteins, right? They have their functions. They can, they can store, or they can protect us, they can regulate things that in our systems, right? And then they can fold, they can expand, all right? And they protect us. Their structures like their functions very greatly, right? So all these proteins are in our bodies, you understand? They can, the structures are different. And when their structures, they go with the way they function, all right? They go by the way they function. Enzymes, which are produced by living cells, speed up chemical reactions like digestion. So if you don't have enzymes, in your body, that means your reactions may also go down. You cannot really, your body cannot really synthesize a whole lot of stuff in your body. So proteins are enzymes that really help to speed up the reactions in your body, right? So I had a friend who had a problem with his pancreas. The pancreas, they secrete pancreatic juice, and this friend, he passed away 2 years ago. You understand? So these organs that we have in our system, you have to be careful with them. You understand? Very, very careful with them. Protect them. I mean, who knows where sickness can come from? But don't do things that will destroy these your organs. The pancreas. This guy, anytime he had to eat, he passed away, like I said, 2 years ago. Anytime he had to eat, he had to take some kind of medicine, and that medicine is a juice. It's a pancreatic juice that will help him to digest his food. So check your lifestyle. We all have different type of lifestyle. Though we are humans. One day we will pass away from this world that we are living, but we don't want to speed up the way we go. You understand? So we need to check up your lifestyle to protect all those parts of our body. So the enzymes that those kind of, for example, pancreas, they will give up pancreatic juice, and then they will speed up reactions, chemical reactions in our body. So these enzymes, they are complex proteins, and each enzyme has a specific shape. right, or formation based on its use. So this enzyme is folded, they like this, curve like that, each use will go by the way they are the function. The enzyme may help break down, rearrangement, or synthesize reaction. So proteins that we are talking about, protein, they have different shapes and molecular weights. And protein's shape is critical to its function, like I keep saying on it. The shape of the protein is critical to its function. Many different types of chemical bonds maintain this shape. All right, maintain this shape. All right, and look at this. We call something called denaturation. Denature. Proteins, you can denature protein. You can denature protein. Right? And changes in the temperature, the pH, and exposure to chemicals may cause a protein to denature. Right? You destroy the shape of the protein. Once you destroy the shape of the protein, you have denatured the protein. Yes, you have denatured the protein. We will close not too long, right? We'll close in the next 5 minutes while you can, denature protein. Look, sometimes when we have, for example, meat, we will cook the meat. When we cook the meat, we'll also fry the meat, right? We have changed the temperature. We changed it. Remember the woman who sells the wachi, Hajia, or whoever sells the wachi, they say, oh, I made a TZ. I'm going to buy a TZ. This woman, her meat there, when you eat small one, you can use it to eat plenty TZ. Yes. Your mouth, is watery, you are enjoying the food, but you're not getting that much, a protein from it. Why? Because the woman cooked the meat and then the woman also fried it. They put it in the fire, they will fry it and fry it and fry it. The meat becomes, you have denatured the protein, right? And because you have changed the shape of the protein, and when you change the shape of the protein, you lead the source of the function, right? So changes in temperature, pH. What is pH? Who can tell me what is pH? What is pH? Hello, my students. What is pH?
Hello.
Yes, Dozy.
Yes, sir.
What is pH?
pH is the acidity of a substance.
Of a substance. Very good. Yeah. What is the meaning of what is the abbreviation stand for?
Oh, that one I can I've forgotten that.
Oh, Kwame,
but it's used to
why are you crying?
Yeah.
Alexander, I think Alexander wants to come in. Alexander, go ahead.
Oh, the abbreviation I forgot about. The pH is just the measurement of the acidity or the basicity of
very good, very good. You all have done well. All right, so the P is the power of hydrogen.
Okay.
Power of hydrogen, right? Changes in the temperature, yes, the pH, and exposure to chemicals may cause a protein to denature. This is the permanent change in the shape of the protein, leading to loss of function. So if you denature it, you expose it to, change the pH, you expose the protein to chemicals, or you change the temperature of the pH, you denature the protein. All right, denature the protein, and then its function will not work properly for you. All proteins are made up of different arrangement of the same 20 type of amino acids. 20 type of amino acids, right? These amino acids are the units that make up the protein. The amino acids are the units that make up the protein. 10 of these are considered essential amino acids in humans, because our human body, 10 out of the 20, 10 are essential amino acids. Because the 10, right, our body cannot bring out those amino acids, all right, those proteins. So we need to eat food. We need to eat. Our dietitian can tell you that, oh, okay, if you eat this food, you get that food, you get the essential, amino acids, all right, the type of amino acids, right? The sequence and the number of amino acids ultimately determine the protein shape, size, and function. The sequence and the number of amino acids ultimately determine the protein shape, size, and function. Then we have nucleic acid that, our friend told us. Nucleic acids are the most important macromolecules for the continuity of life. Right? Those deoxyribonucleic acid and ribonucleic acid. They carry the genetic blueprint of a cell and carry instructions for the functioning of the cell. These nucleic acids, right, they carry the genetic blueprint of a cell and carry instruction for the functioning of the cell. All right. So DNA and RNA, right? So for me, my children will have my DNA. For you, your children will have your DNA. But that dog, the species of dog, the offspring also have the functions, the blueprint of the DNA. All right. That's the reason why, like before, when you go and have an affair with a woman, and the girl knows, oh, Dr. Ben Asante, he has money. Then the woman has two guys. He knows Dr. Ben Asante, I'm a lecturer. Maybe I have money more than Kwajo Manu. Kwajo Manu, is bad boy. Kwajo Manu doesn't have a job. But then the girls, some of the girls, they like bad boys. And then, he goes and have an affair with me, and have an affair with Kwajo Manu. And then he got pregnant. You look at me and say, like, Kwajo Manu impregnate her. So, Kwajo Manu cannot take care of the kids. Let me give the pregnancy to Dr. Ben Asante. He's the one who has money. Then you give the, pregnancy. You call his parents. Oh, Dr. Ben Asante has impregnated me. So then, before, I'm talking about years before. Then they say, okay, now, Dr. Ben Asante, you impregnated our daughter, so you have to really, you marry her, take care of the children, and this and that. And then Dr. Ben Asante will take care of our case because there was no any system that could determine whether I'm the one who really impregnated their daughter or Kwajo Manu who did that. And then I'll be taking care of somebody's child. All because there was no system. Now it's no longer there. So that it's no longer there. Now if any guest come to you or whatever you want to know, go and do DNA test. DNA, deoxyribonucleic acid test. It carry the genetic blueprint of you and then the offspring, the child. Now, even if the woman is pregnant, you can really they can do the pregnancy test and find out, they can do the DNA test to find out whether it's your child or not. And even the child is born, you understand? They can just do that using your even saliva and the child's saliva to find out whether the child is yours or not. So you see the DNA, the importance of DNA. It carries the genetic blueprint of the offsprings, all right? Very, very important, all right? So now, DNA, like I said before, is the genetic material found in all living organisms, ranging from single-cell bacteria to multicellular mammals, all right? Single-cell bacteria to multicellular mammals, all right? Who can give me an example of single-cell bacteria? Who has done biology here before? When you were in high school, I know some of you were in high school, you understand? And then you did biology, I know. So who can give me one example of a unicellular organism?
Amoeba.
Amoeba, right? Amoeba what?
Yes, sir.
Amoeba what? That is amoeba what?
That's what I know, sir.
Okay, amoeba protus.
Oh, okay.
Amoeba protus, and we have Paramecium pudatum. All right. The amoeba protus, it has a contractile vacuole, it has a food vacuole, it has ectoplasm, it has a endoplasm, cytoplasm, and it breaks down by getting its offspring by fishing, right? And it eats by engulfing the food. All those things, it's the single cell. And then we come to multicellular. Me and you, we are multicellular organisms. You understand? So that was well done. Well done for helping the class. So all this, even amoeba proteus, because there is DNA, its offspring, when it produces by fission, by cutting, dividing itself, the offspring will contain the DNA. And you and me, my offspring also contain my DNA. Your offspring will contain every living organism. Their offsprings contain DNA. That's why human beings don't give birth to a dog. Human beings give birth to human being because they contain our DNA. All right. DNA controls all of the cellular activities by turning the genes on or off. It turns the genes on or off. The other types of nucleic acid RNA is mostly involved in protein synthesis. DNA has a double helix structure, and this is the double helix structure. Let me show you, right? It's like this. But before this, let me go over here, and the DNA is an anti-para double helix, right? The phosphate background indicated by the curvy lines is on the outside. The bases are on the inside. Each base from one strand interacts via hydrogen bonding with the base from the opposing strand. This is a DNA double helix structure. All right, this is a double helix structure. I'm going to close from here. We are going to close. Have a nice evening. Go enjoy your dinner. And God willing, tomorrow morning, I'll check the time. I think it's around 10 o'clock or so. I'm not sure, but I'll check it. And the time on the dot, we are going to study our chemistry. All right. Any questions so far before we break off? Any questions so far? All right. So, Alexandra, Bernard, Desi, Emmanuel, Engineer, Ernest, Kingsley. I see you guys tomorrow, God willing. All right. Since you are 19, today all of you didn't show up, but I believe that God willing tomorrow, all of you will come. Hey, Kingsley, yeah, what do you say?
Sir, I wanted to ask of the slides.
Oh, the slides.
Yes.
Oh, the slides, I'll give them to you. You have this in the module book though, but our slides, I'll send them to you guys, okay?
Okay, sir.
You see, this is what you do,
Sir,
Kingsley. Let me finish giving a Kingsley instruction. Kingsley, open a WhatsApp, form a WhatsApp group, make him an administrator, make you yourself administrator. Nobody else. It's predominantly for our class, for chemistry and environmental studies. So make me administrator, make you also administrator, and then make it in such a way that other students cannot put anything on it. Why am I saying so? Otherwise, people will start putting things that will not really help our class. I mean, you guys are mostly mature, but the young ones, when they are going to eat, oh yo, I'm going to have my lunch over this and so place, I'm going to miss my friends. No. So I wanted to be serious on this group. You can form other group that you can have fun on that group, have your chat on that group. You understand? For that one, it's out of my jurisdiction. But I want you guys to really, I want you, Kingsley, to open an WhatsApp group and put all your classmates on it. And when you put them on it, I will put the slides on that, group. All right. And then all the other information that I want to give to you guys, I can put on that group. So somebody was trying to ask a question. Go ahead.
Okay, so it's me, Philip.
Oh, Philip, yeah, go ahead.
I want to ask whether we can access the slide you put it on the LMS.
Yeah, but so far, you make the group, right? You make the group now, and then let me access it and put it on it. That is easier for me. You understand? The most important is for you to get those materials and study on it, and then know information. All right. So you let Kingsley, form the WhatsApp group for now, and then I will put those slides on it. Even the material that we haven't learned, I'll put them on it. And you study ahead so that when you come, it's not gonna be a whole lot of like one man show, but then everybody can contribute something. Do you get it?
Yes, sir. Yes,
you made the WhatsApp group, and I'll put the slides on it for us. Do you get it?
Yes, sir. Yes, sir.
Oh, very good. God will see you guys tomorrow, right?
Hello, sir.
Yes.
Yes, please. Sorry, I joined mid. I was having a meeting, so I joined
Late.
the class midway. Please, how do we get the videos also so that we can go back and listen to it?
The videos,
Those of
you
us,
see, as we
or
are
the
online,
recording.
as we are online now, we hear the ICD support, right? The ICD, you have the support and the co-host and everything. They are doing the recordings. So I will talk to them and see how they can give you guys the recordings. All right.
Okay, thank you, sir.
Sure. But now, today should be the last time that you come to the battle. Me, I don't like lateness, to be honest. I said that in the beginning. Don't come late. Because if I see that you guys are coming late, I'll tell them not to give my video out. The video
Yes,
is
it wasn't intentional. Some of us, like today, it was a strategic meeting.
Ora,
Yes.
me, I don't like that strategy meeting or whatever.
So, this one you have to understand. Some of us are working in IT
Me,
space. If there's
look,
an
me,
issue
when I
of
was doing when
issue,
I was at school, me, I was working full time. Full time. I did that 12
yes,
years in America. So, there's some days you can really, tell your boss. You can tell your boss that, oh, I have, some lectures around this. So please, pardon me, but I don't go and have somewhere and come and tell me that, oh, I have a meeting, everybody will come in
yes,
anytime.
those ones we can do it. But when there's nothing that you can do, then that one it becomes difficult.
Sir,
I'm listening, engineer.
Sir, please, we have to, as the class rep, we have to inform them in the morning. But for me, I thought because they said we will start the lectures on 28th, I thought tomorrow before we will start. So even Kisley called me and
Okay.
he was saying, and I
Oh,
said,
okay.
oh no, it's
Oh,
tomorrow. So we
engineer,
were
I
arguing
understand you
about
now.
it.
For you, your case
So
is different.
we didn't
Engineer,
inform
your
the,
case is different. But what I'm trying to emphasize is
so
this.
we didn't
This is what
inform
I'm trying
the,
to emphasize.
okay.
Listen, guys. I don't know whether we have ladies in there, but I'm saying, guys, you understand? What I'm trying to emphasize is this. For me, Dr. Ben Asante, I hate lateness. Yes. Because, and I don't like excuses. Because when I was a student, when I was living in America, I was working midnight, 12 midnight to 8 a.m. And I was doing engineering. My first degree is chemical engineering. I have associate in chemical technology. My master's degree is in chemical engineering. My PhD is in minerals engineering. All this time that I was schooling in America, I was working midnight, 12 midnight to 8 a.m. Then I'll go to school. You understand? I had to take care of myself to school and everything. So in this case, you as a student, you understand? Even though there may be some situation that it will be beyond your control, that one I can understand. But I don't like excuses. You come in, even if you are going to travel outside, maybe your job, for example, your job has to take you somewhere. You have to pre-inform me. Oh, doc, my job is taking me to maybe so and so place, and I'll come back so and so. But it shouldn't be continuous like that. Yeah, that's why you guys are doing distant. So it shouldn't be continuous. Otherwise, you'll be telling me that this school is nothing important to you, even though you are doing distant learning. But I have to also make time for your studies. It's not for me, it's for you, so that you can study and know something. The degree is fine though. The degree is good for you to get a degree, but you also have to know something to back up your degree. Do you guys get me? Do you understand?
Yes, Doc, we understand you. Sorry, but it's just some of us it's very important for us. That's why we are in the class. For example, I even have my master's, but I just need to do this degree because it's engineering. So apologies for not joining early, but it was just situations beyond my control. For us, I also have people who are under me. They need to go to school. I allow them to go to school, but it was just beyond my control. And in such
Okay.
cases, I will pre-inform you.
Okay, very good. If there's a
Yeah.
situation that is beyond your control, just inform me. All right. Send me a message. Oh, sir, like I said, even if some of you guys job, I don't know the kind of job that you guys are doing. Some of you may travel outside, maybe abroad. Because I had some students when I was in Takrady. Some of my students used to travel to abroad, but they will inform you, oh, sir, I'm traveling to this so place. That one, we know how we can help you. Do you understand? Philip?
Yes, sir.
For that one, you have to let me know so that I'll know my students are there. Do you get it?
Yes, sir.
Do you understand me?
We apologize.
Yes, sir.
Yeah, we
Yes, sir.
apologize
For today, dear, all apologies are accepted because even we were supposed to start like how, was it Bernard who was saying that he didn't know that I was supposed to be 28th? No, today is 27th. All right. So it doesn't matter. We started today.
It's me. It's me.
Oh, okay. All right. Engineer. Engineer, what kind of engineer work do you do?
So I work in cybersecurity.
Cyber
And sometimes
security.
there are incidents. Yes. Yes, I work with a bank. I'm in cybersecurity.
Okay. Oh, I see. I should even know
Yes,
my
I'm an
student.
infrastructure security engineer.
Oh, very good. Kuma, you are the cyber security guy, right?
Yes, police.
Okay, Aita, what do you do?
Yes, sir. I work in a multi-park as electrical engineer.
Electrical engineer.
But yeah, but I joined IET in last 2 years.
You are with the IET.
Institute.
Uh,
No, I just joined.
Institution of Engineering and Technology, right?
Yes.
You know, I'm also part of the IET. I'm also part of IET. I'm a P. I'm a professional engineer with IET.
Okay.
Yes. So, IET, do you have a stamp?
The ID.
No, a stamp. Do you have a stamp?
How is that?
Huh?
Yes, sir.
You have a stamp. Okay. I'm also part of the IET, Institution of Engineering and Technology. Right. Bernard.
Yes.
Bernard.
Yes, sir.
What do you do for living?
I'm maintenance. I'm working with an apartment.
Say again.
I'm working with. Hello, sir.
Yeah, I'm here. I'm listening.
Yes, sir. I'm working with apartment as maintenance over there.
Oh, okay. I see. Hey,
And,
maintenance. I see. Okay, Kanye. Ima, what do you do for living?
Hello, sir. Please, can you hear me?
Yeah, I can hear you.
Yes, sir. So, sir, I'm a security guard at ports, and also at my leisure time, I do picture framing.
Wow.
Yes, sir.
So we are at Gapua. You are with Gapua.
Yes, sir.
Oh, that's excellent. Bernard, have you told me what you do? Ben, what do you do?
Yes, sir.
Ben, what do you do?
Yes, sir. I'm working with an apartment as maintenance over there. At the same time, having my own business.
Oh, you're a businessman.
Yes, Moxie Engineering Solution.
Oh, that's great. That's great. Now, as soon as Doji react with Doji, you haven't told us what you do. Kuma.
Hello. Yes, sir.
Kuma, what do you do?
Yes, please. I said that I'm a cybersecurity engineer.
Oh, you are the one who
Infrastructure
told us you are cybersecurity.
Yes,
Okay.
please.
Kanye, I told you. All about NS Nana Wilson.
Hello, sir.
Yeah, NS.
Yeah, at the moment I'm not working on.
Oh, okay. You are not working.
Yeah, yes, sir.
Okay. And then what about Avoga Kingsley?
Yes, sir.
Sir, please, I'm a firefighter.
You are a firefighter?
Yes, sir.
Wow.
And I'm the CEO for Pure Power Electrical Engineering Service.
Wow. Okay. Lastly, Raphael, what do you do?
Hello, sir. I'm an IT personnel.
IT personnel. All right. So you guys are really, doing very, very
IT.
good. God willing. Now I've took my time. Today I've known all my students, the kind of work that they do, and they are, wherever they are. So God willing will be tomorrow at I think 10 o'clock. I have to double check my time. So tomorrow, when the time is up, I'll see you guys. God willing. Have a good evening. All right.
Sir.
Yeah, Avoga.
Sir, please, I've created a page. So
excellent. So I'll try to, load the listing. There's this thing on it for you guys. Okay.
no, sir. Thank you, sir.
Have a good night.